Hi, good day. Alright, so we're going to look at some questions on finding the equation of the tangent and the normal to the circle at a given point. So here we have a equation of a circle, x squared plus y squared minus 2x plus 4y minus 20 equals 0. So we are asked to find the equation of the tangent and normal at this point here, 5, 1. So looking at the equation of the circle, we know this is of the general form, x squared plus y squared plus 2fx plus 2gy plus c equals 0. So clearly 2f is equal to minus 2, so f is equal to minus 1, and 2g is equal to 4, so therefore g is equal to 2. So knowing the values of f and g, we can therefore find the coordinates of the center of the circle, which is minus f minus g, which would be 1 minus 2. So we have the center of the circle, coordinates of the center as 1 minus 2, and we have another point on the circle, 5, 1. Now the line joining the center to that point on the circle is called the radius. So we could find the gradient of that radius, because that is just a line. So we have the 2 points. Over here is 1 minus 2. Right, so the gradient of the radius is the gradient of the line joining those 2 points. So normal formula, y2 minus y1 over x2 minus x1. Substitute the coordinates and you get 3/4 as the gradient of the radius. Now as you saw in a previous video, the gradient of the radius is equivalent to the gradient of the normal, because if you were to, where the normal would be at this point, if you were to extend a line there, it would be along the same line. So therefore the gradient of the normal to the circle is also 3/4. Alright, so the equation of the normal, well, here you are seeing the formula y minus y1 equals m into x minus x1. What we could do is you could also use standard y equals mx plus c and substitute. So we have the gradient value as 3/4. Right, so substitute the x value and substitute the y value. So we just to be safe, we just take the point on the circle, 5, 1, right? So here is 5, y is 1. Okay, so this is 15 over 4 plus c. So c has the value of minus 11 over 4. So therefore the equation is, now this equation is the equation of the normal. Y equals, so you have the gradient of the normal, 3/4 x minus 11 over 4. As you can see here, we obtain that same answer using this formula here. Okay, we also asked to find the gradient, the equation of the tangent at the same point. Now, in the previous video, it was clear that the tangent and the radius meets at an angle of 90 degrees. So therefore the tangent is always perpendicular to the radius. So the gradient of the tangent would be the negative reciprocal of the gradient of the radius. So we just obtained that the gradient of the normal, the gradient of the radius was 3/4, so therefore the gradient of the tangent is minus 4 over 3. And through a similar process, we were able to find the equation of the tangent. Now, the tangent touches the circle at the point 5, 1, so we need to use that point 5, 1 in our calculation. And we'll find the subsequent equation of the tangent. Or as we are accustomed using, y equals mx plus c So we're just replacing m now with the value of the gradient of the tangent, negative 4 3 over 3, and the x value still remains as 5 plus c, and the y value is 1. And when you solve this, 20 and 3 plus c is 1, right? So therefore c is equal to 23 over 3, and then you'll get the same equation that we have here. Okay, so let's look at our past paper question. June 2012, number 3a. The equation of a circle is given by x squared plus y squared minus 4x plus 6y equals 87. Alright, so we just focus on this part of the question. Find the equation of the tangent to the circle at the point A. Okay, so looking at the equation of the circle, it's in a specific form. And that specific form is x squared plus y squared plus 2fx plus 2gy plus c equals 0. Now notice we need to rearrange the equation so that we have 0 on one side. So we put minus 87 on the left hand side. And just by observation we could see that the values of f would be minus 2 and g equals 3. Just by looking at the coefficients of x and y respectively, and then divided by 2. So directly we could find the center of the circle being 2 minus 3. Right? Now this question, the first part says show that the line x plus y plus 1 equals 0 passes through the center. So all you need to do is use the coordinates of the center and substitute the x and y value, and see that it satisfies this equation. So if I take 2 add minus 3, add 1, I will get 0. So therefore it will satisfy the equation. Okay, so the question asks us to find the equation of the tangent at the point (6 minus 6 and 3). Right, so all we do, we work out the gradient of the radius first. Right? We use that. Remember, the radius joins the center of the circle to some point along the edge of the circle. So we already found the center of the circle as 2 minus 3. And they give us the point here, and they give us the coordinate in the question. As you'd see here, the coordinate is given as minus 6, 3. Minus 6, 3. Right, so simply to find the gradient of the radius, use the gradient formula, you get negative 3/4. So we want to find the equation of the tangent, but as you recall from before, a tangent and a radius perpendicular to each other, and we know the relationship between perpendicular lines. We find the gradients are the negative inverse of each other. So therefore the gradient of the tangent will be positive 4/3. And similarly, we find the equation of the tangent, y equals mx plus c. You substitute, m value is 4/3. The x value would be minus 6, and your y value would be 3. So we need a point along the circumference, because the tangent passes through that point, not the center. Right? Let's see. So solving for c, you'll get c is equal to 11, and you'll then get the same equation that we have here.